Welcome back to the most must-see Flip Geometry Classroom video series on Schoolology, and I am your host, Coach Goop. So today, we're going to be learning about radicals. It's so radical, dude. We're going to learn how to simplify, multiply, and divide the radicals, dude. So first, we're going to start off with simplifying radicals. And guess who's back from Christmas break finally? It's Chalkboard Guy. And he already forgot that my name's Blackboard Guy, but it is I, Blackboard Guy, and I am back here finally from Christmas vacation. I'm going to show you how to simplify radicals. We've got two methods here. Check this out. If we're going to simplify the radical 90, method 1, we can find the largest perfect square factor that divides the radicand, that's the number inside the radical. For example, you see 9 is the largest perfect square that divides the radicand, and then we're going to put the square root of the perfect square. What's the square root of 9? That's going to be 3. We put the square root of the perfect square on the outside and leave the other factor on the inside, so then that leaves us with 3 square roots of 10. That's method 1. And method 2, first we're going to do a division tower. So watch this. I like to do it upside down. So here's my 90, my upside down division. There's 90, and now I'm going to divide only by prime numbers, the smallest ones first. So what's the smallest prime number that goes into 90? That's 3. And then what's 90 divided by 3? I have 30 left. What's another prime number that goes into 30? 3. And then that leaves me with 10. Now what's another prime number that goes into 10? 2. And I know it says to do it in the smallest first, but I'm just doing random numbers. Divided by 2, and then that leaves me with 5. And what's the last prime number here? We've got 5, and that leaves me with 1. When you see the 1, you're done. 1 and done. So then all we have to do is circle the pairs. So right here, there's 1 pair. And then we're going to leave those numbers on the outside. So you see I have a pair of 3s. So I'm going to move that to the outside, 3. And then I'm going to multiply the remaining numbers. That's 2 times 5 equals 10. And that's going to stay on the inside. So then, just like this, you can see right here, they do an example, 3 radical 2 times 5 because this was left over. And then we ended up with 3 square roots of 10. And back to Coach Goo. Alright, that's really cool, Blackboard Guy, but I have another hidden technique, method number 3, and this is another one that's a little more visual. I call it the division tree. So we're going to take 90 here, okay? We're going to make a tree of all the prime numbers that go into it. This is the exact same idea as upside down division, but just looks cooler. So watch this. What numbers go into 90? 2 and 45. Okay, 2 is done. What numbers go into 45? 3 and 15. What numbers go into 15? 3 and 5. And are these all prime numbers? Yes, they are. That means we are done. Now all we have to do is circle the pairs. Bam, there's 1. So that's a 3. And anything that doesn't have a pair, we're going to multiply them together and put them inside the radical. So see, same idea, but just looks a little more visual. That's my secret hidden technique number 3. So now we're going to do some guided practice, and I'm going to show you just how to do these. So look at number 1. For number 1, I'm going to zoom this in a little bit. Number 1, we've got the square root of 72. So first method I'm going to do is the upside down division. 72. What number goes into this? 2. Then that's 36. What goes into 36? 2. Then we have 18. What goes into that? 2. What goes into 18? That's 9. 3. And then 3 and 3. And we're done because there's the 1. So now I'm going to circle my pairs. That's the 2s. Okay, so we got 2 on the outside. And there's a pair of 3s. So that's 2 times 3. What's 2 times 3? That's 6. What's left over? I'm going to use the blue to indicate that. 2s are left over. So that's going to go on the inside. Square roots of 2. So my answer is 6 square roots of 2. On to number 2. Let's do upside down division again. So I'm going to use these inverted colors this time. 400 upside down. What goes into 400? 2. That's 200. 2. That's 100. 2. That's 50. 2. That's 25. 5. That's 20. That's 5. And then 5. 1. And we're done. Let's circle the pairs now. We got 1 pair there, 1 pair there, and 1 pair there. That means we've got 2 times 2 times 5. So what is 2 times 2 times 5? That is actually going to be 20. And was there anything that we didn't use? No, that means your answer is just a solid 20. There's nothing inside the radical. On to the next one, 3 square roots of 20. So the 3 it's already dealt with. We're going to leave that there. So we have to deal with the 20. And now I'm going to use the tree. 20, so that's 2 and 10. That's 2 and 5. And those are all prime numbers. So my only pair is right here with the 2's. So now my answer is going to be this 3 right here times the 2 that's from here. And then what's left over that goes in the radical? The 5. So then my answer is 6 square roots of 5. Bam! And on to the last one, 7 square roots of 16. Only thing I have to find is 16. I'm going to do a tree here, 4 and 4. Then that's going to be 2, 2, 2, and 2. So now I'm going to circle my pairs. That's one pair. That's another pair. So then it's going to be 7 times 2 times my other 2. And my answer is going to be 28 with nothing left inside the radical because it's all taken apart in this tree right here. So you guys try these next 3, A through C, on your own. And I'm going to send it back to Blackboard Guide to show you guys how to multiply and divide radicals. Okay guys, so I'm going to show you how to multiply and divide the radicals. It's 3 simple steps. First, simplify each separate radical if you need to. So that means if you can simplify what's inside the radical, do it. Then you're going to multiply or divide, depending on whatever you're doing, the outside numbers with the outside numbers. And then you're going to multiply and divide the numbers inside the radicals by the numbers that are inside the radicals. Okay, so outside can only mess with outside, and inside can only mess with inside, because that radical symbol, it's like a protective house that's hiding all of the people in hiding. So the people from the outside, the bad guys, can't get inside to the inside. So anyways, step 3, finally, you're going to simplify again if needed. So let's just take a look at some of these in practice. I'm going to do number 7 through 12 with you guys. So let's take a look at number 7. First, what are the 2 numbers that are on the outside of the radical? 2 and 3. We can multiply those together. What's 2 times 3? 6. And can we do anything to square root of 5? No, we can't. That's the answer. Number 8. We can multiply the inside by the inside, right? So square root of, well, what's 2 times 6? That's 12. So then inside, it all stays inside. Now we're going to simplify 12. So 12 is 2 and 6, which is 2 and 3. So then my pair's right here. So my answer is finally going to be 2 square roots. Oh, I don't know why I did that. 2 square roots of 3. Next, number 9. Remember, outside by outside, inside by inside. 2 times 3 on the outside, that's 6. Square roots of 5 times 2 on the inside is 6 square roots of 10. I need to simplify the inside now. So 10 is going to be 2 and 5. So are there any pairs there? No, there aren't. So that means my final answer is, in fact, right here, 6 square roots of 10. All right, on number 10, remember, you can divide outside by outside and divide inside by inside as well. What's 8 divided by 2? That's 4. So I can simplify that into 4. And then what's 12 divided by 4? That's 3. So this actually simplifies into 4 square roots of 3, and that's all you have to do. Number 11, remember, outside can be simplified. 5 over 20, let's simplify that. If I divide 5 by 5, that would be 1. And if I divide 20 by 5, that would be 4. And then square root of 7 is still on top. 1, I don't really need to write that. It's an invisible number. So my final answer would be square roots of 7 over 4. And lastly, number 12. Remember, we can divide inside by inside. So square root of 7 divided by square root of 7, that just cancels out. So then we have 1 over 3 is our final answer. And now back to Coach Goof. All right, guys, so the last part here is rationalizing the denominator. That means you're getting rid of a radical in the denominator because you never leave a radical in the denominator. We don't like the houses on the bottom. The houses are always above land. We don't build houses under the land because we're not moles. So look at this. There's only 2 simple rules. All you have to do is multiply the top and bottom by the radical you would like to eliminate and simplify if needed. What does that mean, Coach Goo? In practice, you'll see it's a lot simpler than it looks. So number 13, do I have a radical in the denominator? Yes, I do. I don't want it there. So how do I get rid of that? All I have to do is do this. Look, multiply top and bottom by square root of 3. Because if I multiply square root of 3 by square root of 3, then that turns into just, it gets rid of the house. Like the house is gone now. It's just a 3. And then on top I have 5 square roots of 3. And then that would be my final answer. Now, why does this all happen? Because square root of 3 times square root of 3. Remember, you can multiply inside by inside. Square root of 3, well, 3 times 3 is 9. And then square root of 9 is what? 3. That's how I got this 3 that's right here. Bam. Because I multiplied this. All right, so look at number 14. What would you do here? What do I not want that I see here? I see a square root of 2 in the denominator. We can't have that, so multiply by square root of 2 on top and square root of 2 on bottom, because this number is really 1, and I'm not changing anything if I'm multiplying by 1. So then this leaves me with 3 square roots of 10, because 5 times 2 is 10. And then on the bottom is just a 2. That's my answer right there. On to the next one, number 15. Take a look at this one. First, we're going to simplify what's on the outside. I can divide 6 by 2 and divide 2 by 2, and that would be 3 over 1. So then I don't want my square root of 2 in the bottom, so I'm going to multiply top and bottom by that square root of 2, and that's going to leave me with 3 square roots of 14 over 2. But now there's another step. I got to simplify the radical 14. So let's take a look at 14. Is that actually simplified? 2, 7, 7, 1. It's actually simplified. The answer is 3 square roots of 14 over 2. Number 16, we got a radical 10 in the bottom. We don't want that there, so multiply both top and bottom by radical 10. And that gives me 7 square roots of 50 over 10. And now I have to find and make sure that this 50 is already in the simplest form. So 50, that goes into 2, 25. And 5 and 5. We got one pair of 5s, and the 2 is left on the outside. The 2 is left on the outside. That means I'm going to have 7 times 5 because of this pair of 5s. And then left inside the radical is just a 2 over 10. So 7 times 5 is 35. So 35 square roots of 2 over 10. Now we have to simplify because both 35 and 10 can be divided by 5. If I divide both by 5, it's going to be 7 over 2, and there's a square root of 2 right here. That's my answer. 7 square roots of 2 over 2. All right, on to number 17. Multiply top and bottom by square root of 5, and that's going to leave me with square root of 5 over 5, and that's my answer. And the very last one, number 18. Multiply top and bottom by square root of 2. That's going to be 10 square roots of 6 over 2. But 10 over 2 can be simplified, so I'm going to chop those down by 2. What's 10 divided by 2? That's 5. And what's 2 divided by 2? That's 1. Square roots of 6. Do I need to write this 1? No, so my answer is just 5 square roots of 6. Okay, so try these last few F and G on your own, and that's the end of these notes. So until next time, see you then. Peace!